Hey guys, welcome back to the channel. Today we'll see how Uber is saving 140,000 hours each month using agents, and we'll see how they have incorporated generative AI into solving business problems. Let's quickly start with the problem statement. This is essentially from their engineering blog. I'm going to share the link with you in the URL. I'm sure in the description. I'm sorry, and you guys can probably go through that in the details, but I sort of extracted important elements, broken it down so that it's easy for all of us to consume and extract the learnings from this, and hopefully maybe implement the learnings in the business problems that we will solve. All right, with that, let's get started. And the problem statement is that Uber's data platform processes approximately 1.2 million interactive queries monthly, and you have multiple organizations, including the operations organization in Uber, which essentially part of that 1.2 million interactive queries. 36% of these essential queries are coming from operations organization, and that operations organization entails engineers, data scientists, as well as operations folks who write queries to derive whatever insights that they intend to derive from hundreds and thousands of tables and databases that Uber has, and you could see this across multiple verticals and domains that they run, right? Now this is a classic enterprise problem. You can think of an e-commerce company or any company. You'd probably have an operations wing which is trying to uh, you know derive insights from the data. And for example, if you have a content operations team, then you'll also have some folks running analytics on how much content was published, what are the assets that were published, trying to understand yeah, the metrics around how that particular data or the content performed. And if it's basically a call center or a support center, then you have folks still running analytics on the lead time and time to complete, and several signals to essentially query. You get the point. Now the problem statement here that Uber was trying to solve was that each of these actors were essentially taking close to 10 minutes to just compose a query and pull relevant information. So if you look at this particular diagram here, you will see that this is how the process looked like. They have a data book. I'm not sure what a data book means. Maybe there is a tool that is called a data book, where they essentially look at all the data sets. If they find a relevant data set, then they run queries on top of that. And there is a tool that where they can write the queries. They get the information or they get the data. If the data is incorrect, they go back to the data set again, find relevant data. So it's a loop. And apparently, just to compose one particular query, they take close to 3 minutes. Sorry, they take close to 10 minutes. Now, you can imagine that if you are, you know, if the data platform is processing close to 1.2 million interactive queries, uh, you can imagine the time that is spent by this operations organization. To solve this, in 2023, in one of their hackathons, a team came up with a solution called QueryGPT or QueryGPT, essentially. Now, this data is of iteration one. They used a simple RAG-based technique to essentially store close to 20 SQL queries, and with metadata information of the table and the schema related information. They also came up with the possible utters or prompts that the user could write, the natural language prompts essentially, for a specific small focused data set. Now they created a few short prompt from this, and then based on the the query, they were able to essentially pull up relevant queries and execute that. They saw that just by doing this, they were able to reduce the time that an operation person takes to compose a query from 10 minutes to 3 minutes. And they saw that there was an improvement of 18% in productivity gain. Now, this is awesome, right? Because you're looking at a simple implementation, a quick implementation in Hackdays that is giving you and a productivity gain of 18%. And like I said, they used RAG-based technique. They vectorized certain utters and stored metadata information for those utters, that is the relevant SQL sample and schema examples. And then they had more, I think, custom instructions, more added context to the to the LLM. And based on the utter, they would identify, they would basically create a fusion prompt through their RAG pipeline, and essentially send that the prompt to OpenAI GPT-4. That's what they were using, and that would return the relevant SQL query. And then the SQL query would also have an explanation of how it was able to basically compose that query, and then they would run that query on their data tool. 18% improvement, good improvement here, right? But obviously, because this was iteration 1 and this was basically a hackathon solution, this was not production ready. Apparently it took them 20 iterations, but we'll see what are the challenges that they faced, from their iteration 1 to the 20th iteration. The first challenge that they faced was that the RAG quality was not good. They saw that the RAG essentially was failing to, solution was essentially failing to return relevant results. Probably that had to do with the kind of prompts that were coming in. Maybe the quality of the utters, or maybe they saw that the prompts were not actually matching with the schema, and that led to a lot of issues. And also, they also ran into technical issues where certain columns in specific schemas had the column count was more than 200, which led to a token count of 40 to 60,000. And as you saw that they are using GPT-4o, which has a context limit of 32 tokens. Obviously, this was failing, and they had to essentially come up with a solution to overcome this particular constraint. And this is what they came up with. This is the 20th iteration. That's what they're calling it. And this is how the architecture looks like. And I'm going to talk about each and every piece here. But essentially, you're looking at an amalgamation of SQL plus RAG plus agent plus, I think, a lot of configuration, custom instructions, and obviously there is gateway involved here, and they're either using Azure OpenAI, and I think they're using GPT-4o today with a context window of 128 token, and then they were able to efficiently make this work and see improvement or saving of 140,000 hours. Now let's break this particular design down and understand how what they essentially did. So the first thing that they did was they curated collections of SQL samples and tailored to specific business domains. Now this is an important there is big learning here, right? Because what they did was the scale that they are operating at, they realized that instead of taking a prompt and then looking up using RAG against the scale or the number of databases, which is hundreds and thousands of data sets that they have, they narrowed down on, basically broke their or sort of decomposed their data sets by domains, and that allowed them to essentially focus on that particular domain and extract the schema and the relevant SQL tables for that particular domain essentially. And to do that, they had to also obviously identify how would that particular query, the natural language prompt, be mapped to the workspace. So an example probably would look something like this. To get queries or extract queries involving trips, drivers, and documents, the query would look like find trips completed by Teslas in Seattle yesterday. This would basically look up, in a domain called mobility, and essentially pull up the relevant tables, from that particular domain or workspace here, right? But like I said, to even talk to that particular workspace and to zero down on that particular workspace or domain, they had to identify an intent, and this is where the intent agent came in. The intent agent essentially helps them to identify the relevant business domain or workspace using the incoming prompt of the user, right? It essentially maps the incoming prompt to the relevant workspace. How does it do that? It uses essentially, now I don't have, they've not obviously gone into the details of how they've implemented the technical details of how that intent agent works. I don't know if there is reasoning capability there. There is a loop. Those details are not available, but at a high level, what they've done, and for us, the takeaway here is that how they were able to solve that particular problem of sifting through hundreds and thousands of data sets, right? So as you can see here, uh, once the user types in that particular query, there is an intent agent that takes that natural language prompt and essentially identifies what that workspace is. My guess here is that this still they are, maybe there is a way they have created to uh, an utter to workspace sort of dictionary, and depending on the kind of prompt that came in, they would basically identify the closest utter and uh, the workspace that it is mapped to, right? And by doing that, they were able to identify the relevant workspace and retrieve the relevant SQL tables for that particular workspace. And they used RAG with that to essentially zero down on um the precise SQL samples just to create a few short prompt and send it to the next bit. Now, you should understand here that the intent agent could probably also have a RAG based or a vector store based intent classifier. I'm not sure. But if I were to implement that, that makes a lot of sense to me, where I have a mapping of all the possible letters to a workspace, and then I simply identify the closest utter depending on the incoming utter from the user, and then essentially identify the relevant workspace, and then pull make a SQL query to pull all the relevant SQL tables and schemas associated with that using RAG, maybe, right? This looks like a very good solution, or at least breakdown of how we can approach these kind of problems when we deal with the scale that if we deal with the scale ever, right? The next part is they once the relevant tables and schemas are picked up. The next part is essentially to tell the user, and here's the best part of this particular solution. Their tool, the QueryGPT tool, essentially is a UX-based tool, just like ChatGPT. And once the user is calling or writing that particular natural prompt, uh, the table agent here helps. This is after intent agent has identified the intent and pulled up the relevant tables. The table agent basically lists out all the tables that it has identified on the screen, and then there is a human in the loop here, where the human or the user can essentially select or acknowledge the relevant tables that were identified, and after that the subsequent actions kick in. Now this is interesting here, right? Because there is a possibility that certain times the few short prompts could return very close very close results, meaning that for a prompt maybe there are tables that actually match the prompt, and it is up to the user to essentially select the relevant tables, and then work with the queries that are generated, essentially, right? All right, so this is how they were able to essentially design the table agent here. The next part is the column prune agent, and we go back to the technical challenge that they had faced, where despite having a 32K context window, and they were using GPT-4 that time I think this was late 2023, and they realized that they were not able to fit in all the columns into the context window. Even after using GPT-4o, and there with a GPT-4 Turbo, which had a context window of 128 token, they were still not able to, in certain cases, uh, fit in the tables and schemas. So what they did was they came up with an agent to essentially remove irrelevant columns from the table schemas and only restrict or have relevant columns for that particular query that is coming in, and essentially generate the query. When I say the query coming in, I mean the natural prompt that is coming in. So I don't. They've not called out an example here, but you can see um, the output of the column prune agent would look something like this. And this makes a lot of sense, right? Depending on the query, you identify only the columns that are necessary for that particular query, and then you pass that as a few short prompt as well, and then extract the relevant columns and then generate the query. And this makes a lot of sense, guys. All right, the last piece here in this particular video is, I think, the most vital and critical aspect of any agent-based or generative AI-based solution. How do you basically evaluate, the query that is generated? Now, they followed two. They used two techniques, and which is probably what most of us have also implemented, and most of the industry also does that, right? One is essentially to use an automated solution. Basically, they're calling it the vanilla flow, where they check the baseline performance using the inferred intent and data sets, using probably a golden question to SQL mappings that they have created. And this apparently was a manual effort, as you can imagine. So they created the evaluation data set and then used vanilla flow to check baseline performance. The other part, which is where you get the human in the loop here to essentially check whether the intent was or the generated query was relevant or not, is basically they created a decoupled flow. And the signals that they used or the metrics that they captured was intent accuracy, correctness of inferred intent, table overlap score, that is whether there was a match between required and selected tables, whether the query ran successfully, and if the query ran successfully, whether there was an output or not. That means were there greater than 0 records. And qualitative query similarity. LLM generated similarity score between output and golden SQL 0 to 1 scale, which is maybe you can think of this as just like the RAG scores. You have a quality score here. Let me actually pull up the blog and we can look at certain details here. You have most of the information captured here. Yeah, like I said, they have followed two techniques here: the vanilla to get baseline performance, and the decoupled one, which is human in the loop, to get the quality, basically collect the feedback. And this is how these are the signals essentially. And the LLM score here is 85%. This is output false. This is how they were able to capture the information. And they run into a bit of limitations with this evaluation technique, right? You can imagine that Uber has hundreds and thousands of data set, and they realized that the user could ask any kind of query. But what they did was to ensure that the evaluation set also made sense. They looked at the previously before that is the tool came into being, on how their data book tool was used, and what are the kind of queries that were asked there, and they focused on those queries only to create that evaluation set. Let's focus on the learnings that Uber has called out here. I want to focus on this particular part here, where obviously they've identified that LLMs are excellent classifiers, but I want to look at this particular one. They were able to decompose this entire workflow into very small, unit of work for these particular agents. So if you do that, the probability of the agent performing really well increases, right? Because one did a single unit of work, you have focused workflows for that particular agent, and the agents are able to do that. And this is something that I'd very, very strongly advocate, and something that I've been trying to follow as well. Even if there are hallucinations, you can still bring in a human in the loop to essentially, uh, you know, get feedback and then continue from there depending on the feedback that you're getting from the human, right? The last bit is very interesting, right? And I want to just read this out for you. High bar for SQL output generated by the LLM. While the version of QueryGPT is helpful for a broad set of personas, there is definitely an expectation from many that queries produced will be highly accurate and just work. And the bar is high. In our experience, we found that it was best to target and test with the right personas as your initial user base when building a product like this. This is not just restricted to a product like this, but any generative AI solution. If you're trying to solve a business problem, maybe execute a workflow using generative AI, I've seen that the expectation from business users is that it'll always work, and all that they care is whether it's working or not. Also, so to get confidence into the solution, to increase adoption, always start with the right persona. This is such an important learning here. All right, guys. Thank you so much. I hope you like this video. If you like this video, please share this with your network, and if you're not subscribed already, please do subscribe and and like the video. Thank you so much. We'll meet in the next one. Bye.